Hi all, welcome back to my YouTube channel. Topic that we'll have a look today is joint probabilities. It's from paper to quants, or it is also a very generic learning which probability and stats or math students are expected to know. So we'll explore this using the example of tossing a coin. Before I move ahead, I strongly request you to subscribe, like, and comment on my channel and share with your peers as well. So let's have a look. See, for example, when you're tossing a one coin and you want to know what is the probability of getting head or tail. So it is very straightforward. When you toss one coin, probability that your outcome would be equal to head is 50%. Similarly, probability that your outcome would be tell is also 50%. So this is wherein only one variable is into the picture. Say for example, if I twist it slightly and if I make it like tossing a coin 3 times, and now say for example if I'm saying that your x variable is number of heads that you get and your y variable is it is number when your first toss has heads. So it is number where outcome of first toss is head. Now if I ask you to plot a probability distribution for this particular experiment. So it's slightly tricky. So that's where your joint probabilities come into the picture. So your x is number of heads, y is number where first outcome, rather I would say here, your first outcome is head. So it is make it a important point. We turn it to the red. Just a minute. Fine. Let me just circle it into the red so that you are aware. Your first outcome is head. Okay. Now let's see how do we tackle this problem. So firstly, you need to understand that you are tossing three coin 3 times. So let's see how we can explore it. So when you toss a coin first time, so your probability of outcome. So what are the possible outcomes are? So once you can get head or you can get tail. And now what happens that we have to explore when we get head and when we are tossing it for second time. So say for example, now we are tossing a coin second time. What are the possible outcomes? So again, this is head and this is tail. Now let's see what happens that in if your first outcome was also head and when you tossed it second time also it was head. In that case, what is the outcome in third? So these are just we are trying to understand possible outcomes. So this is again head. So in third time you get head or you get tail. Just a minute. Yeah. So you get tail over here. Again, in this node also, when you toss it third time, you either get head or either get tail. So this is a possibility when you get head in your first outcome. Now let's explore the possibility when we get tail in our first outcome. So let's see. Over here also we'll do the same. In when you have tail in your first toss, then in your second you can get head or you can get tail. So when this will again explode to the third node, again it will have head or tail. Similarly on this node also. So in your first outcome it was tail, in your second outcome it was tail. Again there are two possibilities in that case also. It's head or tail. So in total, if I were to list down all the probabilities, there are 8 probabilities. How? Let's look at it. So first head, first head, first head. So all 3 heads. Okay. And first time head, second time head, and third time tail. So first time head, second time head, and third time tail. In now we'll explore this node. So when you have first time head and second time tail and third time head. So first time head, second time tail, and third time head. Now first time head, second time tail, and third time also tail. So first time head, second time. Just a minute. I think there is some issue. So second time tail and third time tail. Now we'll explore this node. So tail, head, head. So tail, head, head. Now tail, head, tail, tail, head, tail. Now tail, tail, head, tail, tail, head. Now tail, all 3 tails. So in all 3 outcomes, you get heads, tail. So these are the 8 possible outcomes when you toss a coin 3 times. So if one is smart enough, one can just observe the pattern. It's H H H T T T T T. Then again HHTT, HSTT, then HT, ST, ST, ST. The people who had drawn the truth tables will know it better. But yeah, this is also one of the way wherein you can make yourself comfortable that what are the possible outcomes from this experiment. So in all, just imagine, just for people who are curious, that this was tossing a coin 3 times. So there were 8 outcomes. So when you toss a coin n times, it would be 2 to the power n. So this is a generic case wherein you can just from your learning perspective, you can make a note of it, because in drawing 3 coins toss, the imagine the kind of pain we had. So you can imagine 4 times, 5 times. So this is a better way to know that what are the possible possible outcomes when we toss coin 3 times. Now coming back to our question, now we want to know that probability distribution of uh, joint probability distribution of variable x, wherein x is number of heads and y is number of tails. So if I were to plot the tables, just a minute. Let's see. I mean, how we can draw the probability distribution table. So your variable x is number of heads. So when we are tossing a coin 3 times, you may get 0 head, or you may get 1 head, you may get 2 heads, or you can get all 3 heads. And what is a variable y? It is number of times you get held on the first toss. So it it would be a 1 when you get 1 on your first toss, and it is a 0 when you get no head on your first toss. So let's see how we can find the probabilities using the outcome that we had already drawn. So it is 0 when there is no head in your first draw. Now think of so x is 0, so no heads and head at a first time. So do you think that's possible? So because there are no, you're saying that no head, and you need first head in your toss. So this probability of this is 0. This probability is 0. Now, probability of getting one head and head in the first toss. So let's have a look. So we can see that these are the first four outcome wherein we have head at first toss, and we had to find out wherein we have only one head. So if you see that probability of one head is this only this instance wherein we have head at first L and there is only one head in the outcome. So probability of this is 1 over 8. It is a 1 out of 8 outcomes. So probability of this joint distribution is 1 over 8. Now similarly what we'll have to do, we'll have to check that at first instance it should be head and there should be two heads. So first instance there should be head and there should be two heads. So these are the two possible outcomes, that is second and third. It is 2 over 8. That is 1 by 4. Or let's slide just to make a new consistent denominator. Let's slide it as 2 over 8 only, just for ease of understanding. And outcome wherein so this is a three heads, and this and first outcome should be head. So three heads and first outcome is head is just 1 out of 8. So this is a first possibility wherein first outcome is head and we have a three heads. So 1 over 8. Now what we have to do, we have to check so when I say y is equal to 0, that means there was no head in the first toss, and likewise we can explore number of heads. So the the area that we'll see is these last four outcome, because there was no head in last four outcomes. So now let's see, in first we are looking 0 head and no outcome of head in no heads. So this is a one possibility wherein we don't have a first on the first toss and there are no heads. So possibility of this particular matrix is 1 over 8. So let me draw this table so that you can differentiate between headers and probabilities. So these are the corresponding probabilities of x0, y0. It is 1 by 8 because y0 means no head at first go, and x means that number of heads. So this is the only possibility wherein we don't have a head at first place and there are no heads. Okay? Because over here we don't have a head at first place, but we have some heads in following outcomes. So this is the outcome that we are looking for. So 1 over 8. Now we are looking for an outcome wherein we didn't have head in the first outcome and there is one head in the subsequent outcomes. So one head into the subsequent outcomes is these two are the possible outcomes wherein we did not had head in the first outcome and there is one head in the subsequent outcome. So the probability of this is 2 over 8. Similarly, now we have to look that there should be no head in the first outcome, and in total there are two heads in the final outcomes. So two heads in the final outcome and there is no head into the first outcome. So it should be 2 over 8. And finally, there shouldn't be any uh, head. I mean, there should be three heads and no head at first go. So the probability of this should be 0. I think over here it's total probability is not come, so out is not coming to be 1. Ideally, either of this should be 1 by 8. So let's have a look. Yeah, so one head and first head. So this should be again 1 by 8. So one head and no outcome. So one head and no head at first outcome. So this should be 1 over 8, not really 2 over 8. So this should be 1. So total, if you see that total, all the total of all should be 1. So the exhaustive, I mean, basically, when you draw a probability distribution, it is a function which map your x and y to some probabilities. In this case, it's all this all these are the outcomes of for this and corresponding probabilities. So it is a function, and the probabilities are this should be non-zero, and the summation of all fx y should be 1. So just check the table; it should all be 1. So, and just to summarize this, I mean, if you want, there is a direct picture available over here. But yeah, when we plot it on our own, it gives more understanding. Hope you like the videos. Please, if yes, please do share with your peers as well. And please do comment in the share comment box if there are any suggestions. Thank you very much for stay connected.